Hi guys, this is Mrs. Basaraba, and I'm going to make a recording for you on balancing some equations. I am going to focus in this video on balancing equations that have an element more than once on the same side, like this number 5 here. And then also number 7, I'm going to work one that has the parentheses with an exterior subscript, just to make sure and go over that with you guys again. So what I'm going to do is start out with getting my count. You guys have already gone through counting atoms, and when counting atoms, you guys learn that you're looking for the subscripts, which are going to be the small numbers that are found to the right of an element symbol. So if we're looking at carbon, we know that it has 3 atoms of carbon in this molecule, and hydrogen, there are 3 atoms of hydrogen in that molecule. So I'm going to go ahead and place down my initial count here for this. So for the carbon, I have a total of 3 to start with. For my hydrogen, I have 8. And for the oxygen, I have 2. Now, if I go over to the product side, which is separated by the arrow, my carbon, I don't have a subscript, so it's an understood 1. For the hydrogen has a subscript of 2, so I'm going to place a 2. And for the oxygen, you have 2 oxygens here. Separated by a plus sign, you have another oxygen. So it's going to be 2 plus 1 is a total of 3 oxygens on that side of the equation. So now I want to talk to you just a little bit about how you would go about balancing this. We have to look at why we have the count that we have on each side. Because sometimes if you saw you had a 2 and you had a 3, if you only had the oxygen one time on each side, you would go for the least common multiple to balance those out. But we don't have a 3 due to the fact of that. Our 3 is because we have an O2 plus a 1. And what we have to think about is this 1 right here. If you add a 1 to any even number, it becomes odd. And we know that whatever coefficient that we place right here in front of this O2 is going to be even, because 2 multiplied by any number is going to make it even. So I've got to make this hydrogen right here that oxygen right there become even, because as long as this oxygen here stays a 1, when I go and add it to whatever this oxygen becomes, it's going to remain odd. So something that I could look at too is knowing that my hydrogen is an 8 right here. Well, with my hydrogen being an 8, that makes this a fix for that oxygen also. So if I place a 4 there, that's going to make that hydrogen right here now become 4 times 2 is 8. And it would make my oxygens, they're going to change, but they're going to end up changing again. Overall, my oxygen will become 4 times 1 is 4, but I need to go and add it back to these 2. So right now I have a total of 6 oxygens. But again, that's going to change once I place a coefficient here. So I have 4 plus 2 is 6 right now. So the next step I could look at is this carbon is a 3 over here. And if I place a 3 right here, it's still going to end up leaving this oxygen even, because 3 times that 2 is going to give me a 6, and I would still be okay for evening out. So I'm going to go and place a coefficient of 3 right there. And then that's going to be what happens when you place the coefficients, just to clarify, is it goes coefficient times subscripts. So for that carbon, you're going to say 3 times 1, and it becomes a 3. And then for this oxygen, you're going to have 3 times 2 is 6, but then I have to go and add it to these oxygens that I have right here. So those oxygens, I have 3 times 2 is 6, and then 4 times 1 is 4. So I've got to say 6 plus 4 is 10 on those oxygens. So that's how many total oxygens I have. And a lot of times, like what I will show the kids to do in the classroom is that when we would multiply this, we would go 3 times 2 and write our 6 up here on top, and then say plus, and then I had 4 times 1, 4. And this is really hard for me to use that drawing tool there. But just to show you how I would work in the classroom, but it's a lot more difficult doing it with the drawing tools on my computer. So that's how I got that 10. So now I can go back over here, and I know that I don't need I'm not going to need this carbon or this hydrogen to change it all anymore. So I'm going to check those off because those are balanced. And so I could also go ahead and place my 1 in front of that part of the equation because I don't want it to change. And placing 1s is very important because if you don't place a coefficient, it's the same thing as just leaving it blank. I would mark it wrong. I would take a point off if it wasn't correct. So I need to balance this O2 to the other side, and my oxygen over there is a 10. So I would say, what times 2 gets me 10? Well, 5 times 2 gets me 10. So I'm going to place a coefficient of 5 there, and now that would be balanced. And so everything would be balanced, and I'm going to go ahead and check that off. So my coefficients for this problem would be 1, 5, 3, 4. That would be all the coefficients. Okay, so I'm going to go ahead down to number 7, and I'm going to work through this one. So this one does not have the element more than once, but it does have a parentheses on the product side. So I'm going to go ahead and get my count for the reactant side. So if we look at our iron, there's no subscript, so it's an understood 1. The chlorine, there's a subscript of 3, so there's a total of 3 of those. For our sodium, we have a subscript of 2, so that's how many we have. For our carbon, there's no subscript, so it's an understood 1. And for our oxygen, we have a subscript of 3. So now that we're over here on this product side, you need to do your parentheses before you can do anything else. It's just like with order of operations in math. And so with a parentheses and an exterior subscript, what happens is this exterior subscript is a multiplier, and you have to multiply it by the interior subscripts. So that carbon would have an understood 1, so it would go 3 times 1. So I'm going right above it, 3, and that tells me what my carbon is right now. That oxygen becomes 3 times 3, so it becomes a 9. And I'm sorry how messy this is, but it's, like I said, it's difficult for me to draw with this. So I place those up above that because in the event that I go place a coefficient right here, that coefficient would multiply by those numbers because that's the new count for that carbon and that oxygen. So I'm going to go and put down my count for this side. So my iron, the Fe, is a 2. The chlorine has no subscript, so it's an understood 1. The sodium has no subscript, so it's an understood 1. The carbon is a 3, and the oxygen is a 9. So from here, we would try to determine how we could balance this, and would it work by doing this. So I can tell my oxygen is a 9 over here, and it's a 3 over here. And I would ask myself, can I make a 3 become a 9? And then I know that I can, so I would say, would that work? Could I balance it using that? If it wouldn't balance to the 9, then you would go to the next multiple that 3 and 9 share in common. So, but I'm pretty sure that we're going to be able to balance it to the 9. So we're going to go ahead and go through that process. So what coefficient could I place that would make this oxygen become a 9? A 3, because 3 times 3 is 9. So I'm going to go ahead and I'm going to place that 3 right there. And that is going to make that sodium become 3 times 2. And I'm going to change this color so that I have different colors out here for the new count. So 3 times 2, that makes that sodium become a 6. 3 times 1 is going to make that carbon become a 3. And 3 times 3 is going to make that oxygen become a 9. So now I need to look and see, well, what's not balanced and what can I do? Okay, so if I go and I place a 2 here, what would that do? That would balance this out. So if I place a 2 right there, that's going to make that Fe become a 2, and it's going to make that chlorine become 2 times 3, 6. So now I look to see, well, what's not balanced. Let's go ahead and go through my check marking and see what's balanced. So my iron's balanced, my carbon's balanced, and my oxygens are balanced. So right now, the things that aren't balanced is my sodium and my chlorine, and they're together over here. So if they're both a 6 over here and they're a 1 here, then I would just need to place a coefficient right there that would make them become a 6. And since they're 1s, we just need a 6. And then we would go 6 times 1 makes that a 6, and 6 times 1 makes that a 6. And then now everything would be balanced, and I would just need to go place a coefficient of 1 right there in front of that part of the formula so that it doesn't change. I'm indicating that it stays the same. So your overall coefficients for that problem would be 2, 3, 1, 6. Okay, I'm going to work one more problem, which is this one right here. And so I'm going to go through the process of going ahead and getting the count for this. So my sodium on the reactant side would be a 1 because it has no subscript. My hydrogen would be a 2. And my oxygen would be a 1. So over on the product side of the equation, my sodium is a 1. My hydrogen would be a 1 plus 2, so it would be a total of 3. And then the oxygen is a 1. So this is going to be similar to that first one that I talked to you about of over here on this side, or like our hydrogens are the things that aren't balanced. And over here on this side, this hydrogen has a 2. And anything multiplied by 2 is going to be even. And over here on this side, this hydrogen is 3 because it's a 2 plus a 1. We cannot leave a plus 1. We've got to change that to make it even. So the first thing that would be natural to do would be, well, what's the first thing that we could do to make it even? By placing a 2. If we place a coefficient of 2, it will change all 3 of those, but we'll be able to go back and balance this out. So that's going to make that sodium become 2 times 1, 2. It's going to make that oxygen become 2 times 1, 2. And then it's going to make that hydrogen become 2 times 1, 2, plus the 2 hydrogens right there. So that's how you end up with a total of 4 hydrogens on that side. So can we balance this out? Well, yeah, everything needs to be balanced. So over here on this side, I need this sodium to become a 2 like it is over here. So I can place a coefficient in front of that of a 2, and 2 times 1 would make that sodium become a 2. And then I need this hydrogen to become a 4 and that oxygen to become a 2. So by placing a 2, that would make that hydrogen become 2 times 2, which is 4. And that oxygen will become 2 times 1, 2. And so then we can look to see, is everything balanced? My sodiums are 2, my hydrogens are 4, my oxygen is a 2. So everything is balanced. So in this one spot right here, I need to go and place a coefficient of 1 because I don't want that to change. So the overall coefficients for this equation would be 2, 2, 2, 1. All right, guys, I hope this has been helpful. If you have additional questions, please just send me either a PLP message or an email, and I will return your message as quickly as possible. I have been working on sending out study guides. So when you guys complete the study guide, if you would, please send me a message so that I can go and check it and give you feedback right away. If you missed some problems, I'm going to give you some notes about why you missed them. And then I will be working on sending the test out to you. So anyways, thank you guys. Have a great day.